Hi everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we are going to be learning about antibiotics and painkillers. This is part of the health and disease topic, otherwise known as infection and response if you were learning AQA GCSE biology. If you do enjoy the video, feel free to give it a like and subscribe. Please do join our community here on YouTube. You can also find my videos on my TikTok at the GCSE science teacher and Instagram, where I share lots of content for GCSE biology, chemistry, and of course physics as well. If that interests you, like I said, feel free to subscribe, like the video, and share it with someone else. So let's get started. Antibiotics, remember, is a type of medication, and it actually originated in the 1920s. And we kind of need to know about its origin to some extent. If you're doing GCSE history, you may actually know a little bit about Alexander Fleming as well. In 1928, he went on holiday and came back and discovered his Petri dish filled with Staphylococcus aureus, a type of bacteria, was actually also contaminated with mold. And ordinarily, lots of people would be like, oh, okay, get rid of this Petri dish. We don't need it anymore. However, the Petri dish itself, because it contained the mold, he noticed that the mold was producing a chemical which was actually incredibly useful to the mold. It was preventing it from being destroyed or attacked by the bacteria Staph A. And he realized that this chemical, because it had the properties to destroy bacteria, could actually be utilized in medical industry. So he came up with this idea of using this penicillium, this chemical that the mold had made, to use as an antibiotics, as a treatment method for bacterial diseases. Now, in his Nobel Prize speech, he was very welcome to. He obviously got that from all the other scientists who peer reviewed his work. He did say in his speech that we need to be incredibly careful of the use of antibiotics, especially in the medical industry, because the misuse of it could lead to devastating effects, and actually some of those now we are seeing. So antibiotic resistance is increasing across the globe. I'm going to link some interesting articles in the description box below for you, so you can have a read of some of this, because it is quite fascinating, and we are going to touch on antibiotic resistance in today's video as well. So let's get into it. So in the GCSE exam, you need to know what antibiotics can do and what it most importantly can't do. So antibiotics, like I said, is a medication. It is often in a tablet form. People will take it as a medicine to treat bacterial diseases only. So salmonella, gonorrhea, those types of diseases can be cured with antibiotics. Interestingly enough, people can have a range of antibiotics. Some people are actually allergic to certain ones. Key examples, I know I've mentioned penicillin. However, there is erythromycin, amoxicillin. These are some other types of antibiotics that can be used as well. The thing is with antibiotics, however, it cannot be used to treat viral diseases or fungi diseases or protist diseases, only bacterial. And this is because of the nature of the medicine. Viruses, remember, they need a host cell to replicate. They are non-living, and antibiotics only destroys bacteria. Also, antibiotics can't prevent diseases. In fact, a lot of people think that this is the case. But antibiotics can only be used to treat the bacterial disease. A vaccine is an example of a preventative medicine, but antibiotics should not be given as a preventative. Bacteria have the ability to evolve just like you and I can. However, remember, bacteria actually divide much more rapidly than we do. So one generation of bacteria is much, much shorter in time span than a generation of humans, because bacteria divide through binary fission. They are single cell organisms, and they do this rapidly, exponential growth. And the thing is with bacteria, because they can evolve, they can actually pass on mutations. Remember, mutations can be silent, they can be deadly, but they can also be beneficial. And a lot of these mutations that bacteria have in their genome are beneficial. And remember, they don't just have free DNA in the cytoplasm, they also have extra loops of DNA called plasmids that contain antibiotic resistance genes. Now, what does that mean? So many bacteria are now becoming resistant to certain antibiotics. And that just means that because of the mutations in their genome, these bacteria can actually not be destroyed by the antibiotics. They can actually prevent and become resistant to the antibiotics. So they're actually now coined as superbugs, such as MRSA. And these particular strains of bacteria are very difficult to treat. They're very problematic, especially in the healthcare field, because even though we are giving patients multiple different versions of antibiotics, none of them are seeming to work. And this is increasing in prevalence. There's a lot more cases of this happening now. And the reason is because of the misuse of antibiotics that's been happening for a while. So some of these examples include not finishing the course of medication. So like I said previously, people who take antibiotics, they often take a few pills, maybe for the course of 3 days, 5 days, or 7 days, or maybe even a bit longer. Some people will just take 1 or 2 pills, start to feel better, and then just throw the rest away. That is the worst thing you can do, because obviously if you've been prescribed a certain amount of medicine, you should take the whole amount if your doctor has told you to. And that's to prevent antibiotic resistance, because you're giving the bacteria a very low level of antibiotics and they kind of get used to it and can actually utilize that information to become stronger from it. Also, using antibiotics for non-bacterial diseases. So back in the 1920s and in the 1930s and 40s and 50s, a lot of people were given antibiotics because it was seen as this amazing, super new drug that could treat all illnesses. But as we know now, they should only be used for bacterial diseases, not viral diseases or any other diseases. And also the overuse of antibiotics, especially in the farming and agricultural industry. Lots of cattle, chickens, pigs and other farm animals are given antibiotics to prevent them from getting diseases. And like I said at the beginning of this video, antibiotics is not a preventative medicine. However, it can be used in that way to make sure that animals and livestock are not getting diseases, especially if they are living very close together in the farming industry. And that obviously can have a big knock-on effect of how the efficacy of these drugs and how well they work in the future. Okay, so here is the last type of medication we're going to talk about today, and it's called painkillers. Now, this is not the same as an antibiotics. This is a different type of medicine, which, as the name would suggest, is utilized to alleviate the symptoms of pain from different types of pathogens that cause disease. Remember that antibiotics is only used on bacterial diseases. However, painkillers can be used for a range of different diseases, regardless if they are caused by bacteria. Remember though, painkillers do not cure diseases. They only alleviate the symptoms. They make someone feel better. And often the reason for these painful symptoms is because of the toxins that pathogens can produce, specifically bacteria. So one example is paracetamol, another is aspirin. We are going to talk about the origins of aspirin and how we actually create different drugs and the different stages in terms of drugs and how they are created in a future video. So keep an eye out for that one. And that is it from me. Thank you so much for your time today. I've been the GCSE science teacher and you have been curious. If you did enjoy the video, please feel free to subscribe and join our community here. You can also find me on my Instagram and TikTok at the GCSE science teacher. And if you would like to see more videos from myself, whether it's biology, chemistry or physics GCSE revision, I do have some playlists which I'll leave on the side for you and my previous videos as well. Thank you so much for your time. I will catch you in the next one. Have a great day.